Hi guys. Just confirm me whether I'm audible to you. Hey, for the one last time. Yeah, okay, good. Today it's going to be a very important lesson. Because why? Today it's going to be, we are just about to learn Newton's second law of motion. What? Newton's second law of motion. Before going for Newton's second law of motion, I would like to remind you some basic things. Right? Some basic stuff. Right. In this basic stuff, we need to know about resultant force. Because we know how to get the resultant vector, this one is in the same way as of what? Obtaining resultant vector. Right? We happen to know one thing. What? When there is a force of P and there is another force of Q, and in between P and Q there is an angle of theta. Right? Can anybody speak up, please? Because without hearing somebody's voice, I don't have the feeling to go along. බලමුද කවුරු කවුරුද ඉන්නේ කියලා? Let's see. Right. සහසයක් තාම නෑ වගේනේ. Oh my god, this is all going to be a Mahila Sangam something. All the girls. Wow, there is a one guy, Chalaka. Thanks God, Chalaka is there. Chalaka, hello. There's a bit of construction is going on, that's why it makes some noise. Okay, so Chalaka පොඩ්ඩක් කතා කරමුකෝ. Chalaka. හරි ඔය තියෙන්නේ. හරි. ඉන්නකම voice එකක් යවනවා. හරි. දැන් බලමු ගෑනු ළමයිගේ voice එකක් අහලා. Ekangi, I think you can speak. Ekangi.
Sir.
Hello. ඔය තියෙන්නේ කීර්තනා.
Yes, sir.
කීර්තනා එලා හිටියේ. And the last one, Tirasha, the new one, but she speaks.
Yes, sir.
වෙන්නේ. හරි. Okay, හරි. So between P and Q, how to find out the resultant? We used to know this one. The resultant force. How? We had an equation R square equals to P square plus Q square plus 2PQ cos theta. This is what I had as the equation. Right. So everybody, I think they are just kind of used to this equation. හැමෝම මේ equation එක use කරන්න පුළුවන් නේ? If anybody has a certain doubt and who doesn't know, then let me know. I will put some simple example over here and show you the way. This is really important. That's why I'm asking you. Guys, hello. Is there anybody who doesn't know how to use this one? ඉන්නවද කවුරු හරි එහෙම? නෑනේ? Right. Okay. So if anybody has a doubt, without failing, just inform me. I will show you the way how to calculate. Right. 2 weeks ago, the other boy who doesn't participate today, who just told me that his father is sick something, who sent me a certain calculation like of jumping out of a parachute. So if he was there, then I could have just asked you. He couldn't recognize how to find out the resultant acceleration. As it says deceleration, the dude took it like because he knows that gravitational acceleration is 10 downwards. If that is deceleration is 2, then he calculated the answer with like 8 as the resultant. It's wrong because why? It says the deceleration means has to go in the opposite direction. So this theory is really important. Why? When there is a certain object like this lying on the surface, when you drag it by a new, I will go for numerical one, 10 Newton to right hand side and another 10 Newton to left hand side. So how about the resultant force now? What about the resultant force? The resultant force is 0. So this is somewhere the object behave according to Newton's first law of motion. Why? The reason is that all the forces along the horizontal direction is to be balanced, and the vertical forces showed us the same way. Mg is being balanced by the reaction force. That's great. But if you provide another 8 Newton to left hand side, another 8 Newton to left hand side, what is it going to be the resultant? It is no longer 0. It's no longer 0. What is the resultant? Because this 10 being cancelled out to this one, but there is a certain force that is the resultant. The resultant is 8 Newton towards the left hand side. This is what we have to understand. Do you have any primary idea about this resultant force? Yes or no? Yes or no? තමයි ඔය શબ્ද නැති එකට මම හරි ආස නෑ. Yes, good. අද ඉන්න සෙට් එක බලන්න කවුරු ඉන්නේ කියලා. කවුද අද මිසින්? මේ කාංගි චලක සිඩ්නි රසිනි ශ්වේතා තරුසි තිරාෂා. තව සෙට් එකක් ඉන්න ඕනේ අද එන්න. කොහොමද ටිකම කොහෙද කියලා තියෙන්නේ. හරි. Right. Now, firstly, you need to find out the resultant force. The Newton's second law is not a hard one, right? Newton's second law of motion is not a hard one at all. At any instance, it is not hard. That's a really simple thing. So does the Newton's first law. Newton's first law is kind of tough because it has to resolve all the forces in along the direction and consider like whether stationary or moving. But Newton's second law is really easy. Why? Whenever you have a certain resultant force, it's going to get accelerated towards there, right? Like that. So when I put some pressure on the force on the floor, I'll get pushed forward. So that's why I just move like this. Okay. So the resultant force. Okay. So that's why I had no intention of teaching you Newton's resultant force factor. I added all the thing in my tube. That's a very long tube, like 38 page one. Study kara de. Because now only I am going to teach you Newton's first law by theory, Newton's second law by theory, Newton's third law by theory, and finish the entire Newton's third laws today. Hey guys. By the way, how did you feel about the friction worksheet? D1 sent me the answer on the spot in the same day, within few hours spare. And T1, that means Tarushi, sent me the answer in the following day. And sorry, Devmi and Sahas. Others are kind of really creepy. Why? Aye. You did it, but you have no source to send me. I know that. Because you are in hostel, you have no access to phone. I know that. But if you did, that's enough. Yeah. I know. You have some kind of problem with it. Okay. So, by the way, others, why don't others send me the answers? මොකද මේ සතියේ මම පොඩ්ඩක් වැඩි වෙලාවක් ගත්තා to make the tute, because it was a very big tute. It should cover all the theoretical parts, all the parts that may come in the exam. Exam එකේ එයි කියලා හිතන හැම පැත්තම මට cover කරන්න ඕන. So I had no other option. I had to stick to the plan and take some time. හරි. මොකද friction කියන කතන්දරේ ගොඩක් ළමයින්ට හරියට ඇඟට වදින්නේ නැහැ. ඉතින් මම ඒක ඇඟ ඇතුළටම යන විදියට තමයි ඒක හැදුවේ. ටිකක් කල් ගියා. Okay. So I hope that you have no other what kind of. Okay. Let me explain you one thing here. Okay. Now this, consider about this object. If I drag this along to the right hand side by a certain force. What is? What the heck? What the heck does he say? Was just added to the group. Can you please send it again? What the heck? I sent it to the both groups. You were in one group before. Midweek worksheet. Okay, midweek worksheet is a really important one. මම ඒක දැම්මේ නැත්නම් දෙවෙනි group එකට යනවා මතකත් නැහැ. No, 35th I think. 35th one. The friction one. Okay, have a good look at. If you just try to push this to here, there might be some resistive forces as well. This hand just trying to push this to right hand side, the other one pulls it to the left hand side. So if both the forces are equal, it doesn't move, or just moving at constant velocity. Even under resultant force of 0. But if you put something very hard on the other, by my left hand, imagine I only put like 20 Newton, but my right hand puts it like 30 Newton. So it will get accelerated, right? It will get accelerated. So this acceleration is governed by Newton's second law of motion, right? So the action-reaction pair is completely controlled by a law called Newton's first law of motion. this one. When I impart certain force on my left hand, so my left hand does the same trick on my right hand, it's going to impart a force exactly evenly on my left and right. Right hand puts a force on left, so that the left hand puts the same amount in the opposite direction in the right hand. So that's what Newton's third law. Now I'm going to teach you Newton's first law, Newton's second law, Newton's third law by theoretically and apply in many calculations and make it easy. I'm going to firstly give you some easy tute, and in the midweek worksheet you will find the real devil like so far in the exam level questions. All right. Today I'm going to firstly solve the friction thingy, friction mystery. Firstly, how to resolve all the mystery about friction, that tute, the worksheet, midweek worksheet. After that, I'm not going to discuss all the entire questions. I'm going to take like 4 questions and resolve. Then after going to teach you Newton's first law, Newton's second law, Newton's third law, and finish the entire Newton's laws of force lesson. After that, according to your call, right? I'm going to get some word from you, like whether to do it like some questions in the next week or straight away for going for starting momentum. It's up to you, you decide at the very last moment of today, not now. Okay, shall we move on to our lesson? Okay, guys. Harid, Akian. Okay. A 10-kilogram block rest on what? Lama, am I audible? I can see something terrible is happening here. Because lack of a signal level or something, I feel like. Do you hear me with some lagging? Hey, how is my audible level? Do you hear me with some lagging? Yeah, I can feel something like that because my other device shows the stuff really later. Guys, okay. Now let me know, am I just kind of lagging or not? I think I might not be lagging now because I changed the device and the kind of network connection and all. Now might be I am audible enough. Let me check. I drew a line and the line drawn at the same time. That means I am audible. Am I audible, Lamai? Yeah, okay, good.
whenever something happens, just let me know. That's why I'm using two devices. And if I see my other screen is frozen, the screen frozen means kind of network issue is there. So you should also tell me if I'm getting lagging, because I have like 3 connections. I change from one to the other to the other, like that. But if all 3 doesn't work, I have no other option. It's kind of matter of luck. It normally never happens. So, like, you will learn there is a phenomena called what? Constructive and destructive interference of waves, right? If the waves were, 2 waves were meet at like this way, it will definitely increase the signal strength, is called the constructive interference. But if the waves meet at this way, one wave meet the other one in this manner, what is going to, this positive half is going to cancel out by the negative half. The resultant is a very weak wave now. So sometimes it happens. So accordingly, one network might get due to some clouds and other changes with constructive interference. So you get maximum signal strength. But if this arrangement comes, so it becomes the other way. All 3 networks might get the same thing. It's like very bizarre condition, but that one also had happened to me in recent past very rarely. So you will get used to know this thing in the waves lesson, not now. It's all about physics, right? Okay, a 10 kilogram block is rest on a horizontal surface. Draw a free body diagram showing any and all forces acting on the block. Compare the magnitude of these forces. A block rests on a horizontal surface like this. So we don't want to do any stupid things and just mark what the weight on it, weight, and the reaction force from the, this is what reaction and the weight. There might be some other forces. We don't want to worry about that. So just mark these two. That's all, more than enough. If the engine of a 1000 kg car exerts a force eastwards, that is 500 Newton. Eastwards, some 500 Newton, while the friction of 100. So draw a free body diagram on this car on horizontal surface. You don't want to find out the result and know anything. Just draw the free body diagram, and the 1000 kilograms means it exerts some 10,000 Newton downwards, and the reaction force to upward. This is all you just need to draw. Got the point? Understand? Lamai? Okay, great. If a force of 20 Newton is applied to 4 kilogram object in order to drag it across a table, and the object accelerates at a rate of 2 ms minus 2. Accelerates at 2 ms minus 2. The force of 20 Newton is applied on, right? You don't know this part yet, but what is the frictional force must exert between the object and the table? Draw a free body diagram to help your question, right? The force of what? 20 Newton. You might not know, because if you know your basic knowledge of Newton's second law of your O level, you can do. If you don't have, just leave it. So we better leave this. Just leave. Just leave. Right? පොඩ්ඩක් අපි මේක අතාරිමු. අද දවසේ තව පැය කාලක් යනවා. Right? Okay. මට මේක ලස්සනට හදලා එව්වා අපි අර හදපු තුන් හතර දෙනාම O level physics. F equals ma, nothing else. But today I didn't teach you so funny. So I'll just leave it for you, for convenience of the majority. If a force of horizontal force, which is 15 Newton, applied to 50 Newton block towards east, is just enough to cause that the block to start move. What is the maximum static friction? So the 50 Newton, the force of 15 on a 50 Newton block. What does it mean, the 50 Newton block? What does it mean, the 50 Newton block? Lamai, 50 Newton block means the weight of the block. The weight is some 50 Newton, right? As the matter of fact, there is a reaction force that balances this 50 Newton. And this 15 Newton is nearly enough to overcome what? The resistive force. The resistive force is nothing other than, my friend, friction. Understand? තේරුණාද ළමයි? ඔව් කියන්න තේරුණා නම්? You get the point? Hi guys. Understood. Really good. Oh, අද අමන්ද නැද්ද මන්දනේ? ගයාසි. ගයාසි නේද අලුත් ළමයා? කොහොමද ළමයි? ඔයාලා දන්නවද මං අද වීක්ලි බයිට් එක දෙන්න හිටියෙත් අමන්තට. මිනිස්සේ අදම නෑ. හිටියානම් එහෙම දෙන්න ගිය අර වීක්ලි මාරුවෙන් මාරුවට කට්ටියට මම බයිට් එකක් දෙනවනේ. ඒකට අවශ්‍ය පැක් ගොඩාක් හම්බුණා දෙන්න ගියා. I think ඔයාලා බේරෙන්න බැරි. බුලට් එක අද නෑ. එහෙනම් මං අද කාවද අල්ලගන්නේ වැඩේ? ඒකට හරියන්නම රිප්ලේස්මන්ට් එකක් හරියට කාව හරි අදාළව බයිට් එකක් දෙන්න ඕනේ. නැත්තම් නිකන් කෑවේ නෑ වගේ. මම ඩිසයිඩ් කරන්නම් මේ ටික ඉවර කරලා. කාටද අද දෙන්නේ කියලා. Right? Okay. What is the maximum static friction? So, according to this diagram, see, there is a 15 Newton force. This should be balanced by the other force. What is the other force? That is this friction. So, what is the maximum friction force? Friction force is 15 Newton. What is the direction of the friction force pointed? You told, sorry, in this question it says, if a friction force of 15 Newton applied to the east, towards east, where should the friction applies in the opposite direction? Towards what? Towards the east, west. මෙයා තියෙන්නේ east නම් the other one is west. Now as calculate the shit. This is the simple mu static. Mu static. That means the frictional coefficient. Right. To find out the frictional coefficient, we have a simple equation. F equals to mu r. This is what my equation is going to be. Right. We know the force and the reaction. What is the reaction? So according to this diagram, we can find out the reaction is equals to 50 Newton. Good. So the force is what? 15 mu times 50. Right. How to get the 15? Mu equals 15 now 50. 15 now 50. How many? 3 there. And how many fives? 25. Sorry. 10 fives are there. So what is it going to be? Mu equals 0.3 because no units for the frictional coefficient. I taught you that in the last week. මතකයි නේ මේ කතන්දරේ? ළමයි මතකයි නේද කතන්දරේ? Yes or no? Let me know. Good. That's great. After the block is set in motion, a 9 Newton force is necessary to cause the block to move at constant velocity. Right. Calculate mu kinetic. As I told you, you can remember the graph in the last week, what we drew. The driving force and the frictional force, and it changes like in this manner. So the maximum one is known as limiting friction. The other one is known as dynamic friction. Again, D, but I will use that simple D, dynamic friction. Okay. So the dynamic friction is a low one. Fd equals to mu d times r, and we know r doesn't change, it's the same r. F drops to 9, and this mu times what? R is 50. Mu d equals 9 over 50. So you can get it like what? 18 over 100. Isn't that? So how does it look like then? 0.18 with no units. මේ ටික තේරුණාද? Guys, can you understand this one? How? Yeah, good. Really good. Okay. So, sixth one looks good. Sixth one looks good. So let's, I will explain you the sixth one quickly. Need some spacing of this one. Okay. Right. A brick with mass of 4 kilograms is placed on a horizontal surface. The force of 15 Newton is needed to push the brick towards the west with constant velocity. With a constant velocity to the west. So it's like 4 kg one, and the force of what 15 Newton is put on the brick towards the west with a constant velocity. The velocity is going to be like constant, we don't know. So one thing I told you, if the object is stationary or moving at constant velocity, it is governed by a law called Newton's first law of motion. That means the forces are completely in balance. Right, the 15 Newton force is needed to push the brick towards the constant velocity. What is the magnitude of the frictional force? It should balance this. So the frictional force is in the opposite direction. See, right? You put some 15 Newton here. It should balance the frictional force at the right hand side. Where is the frictional force now? Frictional force is nothing other than 15 Newton. You have to understand this concept behind this. ඔයාලට මෙන්න මේ concept එක නම් තමයි තේරුම් ගන්න. concept එක තේරුණාද නැද්ද කියලා කියන්න බෑ. හා? ඔයාලට concept එක තේරුණාද නැද්ද කියන්නකෝ. Okay. What is the magnitude of the normal force? Explain your answer. Understood. Good. the magnitude of the normal force is 4 kilogram. So it's like 4G is equals to R, not 49, 4G. Yeah. So R equals 4 times 10. R is what? 40 Newton. Determine the value of coefficient of sliding friction between the brick and the surface. This is a sliding friction. So FD equals to mu D and R. So you know the force. What is it? It is this 15 Newton, the driving force. And what is the reaction I just found? So you can easily apply to this equation and find out the R. Is like 15 over 40. So, then the form to the 7.5, 3.75, 3.75 divided by 0.375 is equals to the frictional force over here, right? So, coefficient. මේ ටික තේරුණාද? තේරුම් නැති කවුරු හරි ඉන්නවා නම් මගෙන් අහන්න. මම ඉතින් තරම් කියලා දෙන්නම් ඔය දේවල් ටික. මේ ටියුට් එක කාගාව හරි නැත්නම් ඒත් කියන්න ළමයි මම ටියුට් එක දාන්නම්. කාගාව හරි ටියුට් එක නැද්ද? Is there anybody who doesn't have the tube? එහෙමත් ඉන්න පුළුවන්. ටියුට් එක අතේ නැති කවුරු හරි ඉන්නවද? Is there anybody who doesn't have the tube? Oh, shit. He don't have. Okay. තව කවුද ඉන්නේ? තව කාටද ටියුට් එක නැත්තේ? මයි. හරි. මම ළමයට විතරයි යවන්නේ. එතකොට එයාට විතරයි ටියුට් එක නැත්තේ කියලා මම හිතනවා. I hope that she is the only one who doesn't have the tube. Like that. කවුරු හරි ඉන්නවා නම් කතා කරලා කියන්න. So is there anybody who doesn't have the tube? Midweek worksheet 35. I'm talking about this one. ඔය ඉන්නේ මම උකුර ලයිව් රහ වෙනකන් කෑ ගන්න ඕනේ මේ ටියුට් එක නැහැ කියලා කියන්න. අරුයි. තව ඉන්නවද දන්නේ නැහැ ටියුට් එක අතේ නැතුව සබ්ද නැතුව ඉන්නවා. සුගෙලින්න එපා ළමයි. වෙලාව නාස්ති කරන්න බෑ අපිට. හරිද? We have no time to fool around. Okay. That's enough. Huh? I gave you enough time. Let's do the 7th one. No, let's do the 9th one. 9th one and finish for today. Sorry. Today maybe friction katawa finish karamu. Not the entire lesson. I'm talking about friction. Let's finish it for today. And let's learn the other part likes of the Newton's second law, Newton's third law, Newton's first law with theory, and do some questions. And that's all. Okay. Right. A sled with a mass of 50 kilogram is pulled along snow-covered flat ground. Static coefficient of friction is mu s. Mu s means the motionless stuff. Static 0.3. Sliding kinetic coefficient of friction is 0.1. Slow value. Okay, what does the sled weigh? It's like sled is of mass is 50. The weight is like what? W equals to mg. So m is 50 times 10. It is some 500 Newton. That is the weight. Right? Okay. What minimum force will be needed to start sled moving? Okay. Talking about this graph again, I will draw the graph again because I want you to understand this stuff. The graph is something like here and drops. So the maximum thing is the limiting friction. You should know that the limiting friction at here, the static friction is maximum. Stat is max. Stat is at max. Right. How? If the static friction is maximum, F static limiting is the one we want to find out. Static times R. Okay. Now the minimum friction force is equals to the frictional force. You have to overcome the frictional force. So that is the maximum thing. So if you just find out the maximum friction, that is the minimum force. In terms of the friction, that is the maximum. In terms of the moving force, that's the minimum. Okay. US is 0.3 and the weight I just found 500. So it's like what? 50 from here and like 10 is gone. So 10, it's like 150 Newton. 150 Newton. Just ask me if anybody who doesn't understand this well. Is there anybody who can't understand this way? මේක තේරෙන්නේ නැති කවුරු හරි ළමෙක් ඉන්නවා නම් කියන්න. Right. What force is needed to keep the sled moving at constant velocity? Now at constant velocity. Have a good look at if that is constant velocity, what friction is applying now? What friction? We have to go and just ask ourselves, what friction? What friction? What the heck is the friction here? That is this friction, kinetic. That is the kinetic friction. Mu K, Fk is like mu k times r. R is the same, and mu k is like 0.1 times 500. You just need what? 50 Newton as the driving force to move under constant velocity. ළමයි මෙතන කෙමිස්ට්‍රි කරන කට්ටිය කී දෙනෙක් ඉන්නවද? Even though I asked you, like, it is not going to work well because none of you still know about the what is called activation energy soapane. Okay, activation energy ගැන ලොකුට දන්නේ නැහැ වලනේ. You guys don't know about the activation energy soapane? A bit, right? There's a thing called activation energy. So as to carry out certain reaction, there are certain reactions called exothermic. Actually, it produces heat. It produces. So it's exothermic. That means produce heat, but it is not automated. Why? Firstly, you have to provide this activation energy. Then only it begins. After that, it is automated. After that, it is automated. You have to push it forward hard to give the kickstart. Right? You have to push it very hard to give the kickstart. Like here, if you exceed 150, then you can enjoy the force at 50, just 50. But the start is the hardest thing. Once you get the start, you are unstoppable. That's even in your day-to-day life. අපේ දිනදා ජීවිතේ අපි kick start එක ගත්තොත් වැඩේ කොට, but unfortunately we are not getting. Now the third one, have to learn what? Newton's second law of motion. So let's just wait. That's good now. Let's just wait. පොඩ්ඩක් ඉමුනේ. එහෙම නේද ළමයි? ඔය ඒ කියන්නේ හරිනම්. අපි ෂූට්ටක් ඉමු. Okay. Lamai, move to this tube. Move to this tube, Lamai. Types of forces, subthrust, electromagnetic. I explained these things already so far. Adding forces and subtracting forces. I gave all lot of notes since I have no intention to teach you. මේ දේවල් හරි ලේසි ළමයි. තේරෙන්නේ නැති කවුරු හරි ඉන්නවනම් අහන්න කියලා කිව්වා හැමෝම කිව්වා තේරුණා කියලා. So I have no intention to teach. In biology, activation energy quicker than chemistry. So I did little research. You did. Okay, good. Okay. සහස්ත biology වල තිබිලා. enzyme වල රෙහිමේ තියෙනවනේ scene එක. මේ ළමයි මේ pages ටික තනියෙන් try කරන්න. Right? You have to try this page alone. Okay, guys? This page is really important because I have no other intention to teach you myself and taking our time and our valuable time. And the resolving. Resolving is also needed here. I taught this all shit in extended way in vectors. Vectors ගැන කවුරු හරි බැරි අලුත් ළමෙක් ඉන්නවා නම් ළමයි, if you are really new and if you are kind of feeling difficult in vectors, මට කියන්න ඔය ළමයි දෙන්නෙක් අලුතෙන් ඇවිල්ලා ඉන්නෝනේ. අනිත් කට්ටිය නම් මම දන්නවා මගෙත් එක කලින් ඉන්න හිටියානේ. So, Tirasa. Tirasa,
Yes, sir.
how about you for this, what is called vectors?
I did this part already, sir.
Did it
Yes,
or
sir.
did
Sorry?
it or didn't?
I did it.
Yeah, are you comfortable with it?
Yes, sir. Of
Okay,
course.
if you are comfortable, it doesn't matter. If you are not comfortable, please join to the second batch class, not in the next week, the week after that, because I'm going to teach that vector part again right from the beginning. හරිනේ? පාඩේ ප්‍රශ්නේ නැහැ. හරි. Gayasi, how about you? Do you have any problem with these vectors and resolving and get the result? Gayasi, Gayasi,
Yes, sir.
how about your proficiency with the vectors? Are you really good at or really bad?
Somewhat okay, sir.
Somewhat okay. That somewhat okay means somewhat bad, somewhat hard. Isn't that? You have two options. One is asking me for the previous video for the vectors and practice yourself alone, or joining to the second batch class for the next 2 weeks and get it completely learned. Because in that class, I teach faster. Right? ඔය ඔප්ෂන් දෙකම තියෙනවා දෙකෙන් ඔයා කැමති එකක් ගන්න අරගෙන හරියට හදාගන්න වෙක්ටර්ස් නැතුව මුකුත් කරගන්න බෑ හරිද okay by the way it right the resolving is a really important thing the friction I gave you all the notes here see the way good examples are there I've calculated and with all the examples see මෙතරම් examples වල වෙන කොහෙන්වත් හම්බ වෙන්නේ right no need to talk about that again because we just did right now it's about Newton's laws of motion so there are many Newton's laws so I need you to read these entire 3 pages yourself not only 3 there are 4 pages just read these 4 pages and try to figure it out yourself if you can. You will understand somewhat. ඔයාලා මොනවා හරි තේරුම් ගනි ගෙදරදී කියවන්න කිව්වට කියවන්නේ නැහැ නේ. මම රෙකෝඩින් එක පෝස්ට් කරන්න no need to record this reading time. Okay. Right. I just need to know one thing. One simple thing from you. One simple thing from you. කතා කරන්න පුළුවන් අය. Could you recognize some weird words you have never heard before? කලින් අහපු නැති අමුතු වචන ටිකක් තිබුණා එහෙම දැක්කද? Huh? Newton's laws of motion here, because we have three laws. Use third law source like action reaction first law. Zero acceleration. This one you know already. So how to look at here? Is this word familiar to you? Word inertia, is that familiar to you? Is that familiar one to you? Very much. Yes. Good. It's really good. Others? සමහරුන්ට ඒක ඕනට තුලා familiar. Right. These are the ones I just need you to understand. Like this phenomena you have just seen in your day-to-day life every day. But this is the first time it comes to you as what? As a kind of what? So see the escaping the elephant thing even, because if you just run in zigzag way, because of high weight, inertia, the elephant can catch you. Right. Write the first law, Newton's first law of motion. Newton's first law of motion. This is the first one. Newton's first law of motion. Write it. Write the first point. Write it. Unless an external and unbalanced force is not applied, unless an external and unbalanced, unless an external and unbalanced, but unless an external and unbalanced force is applied, unless an external and unbalanced force is applied on an object, the object remains stationary. The object remains stationary. Object remains stationary or move at constant velocity. For move at constant velocity. Right. If the forces are balanced, what happens? It would prefer either to be stopped. That means stationary. Stationary condition, or in the dynamic condition, in what way? Under a uniform velocity. Stationary or moving at constant velocity. This is called constant velocity. Right. Copy this thing. Copy these two diagrams. This is what all about Newton's first law. Great. That's what Newton's first law. Okay. Now write the next one. Newton's first law of motion. We have done many examples. අපි මේක example කරලා law එක ඉගෙන ගන්නත් කලින් ඉතින් මම බොරුට examples දෙන්නේ නැහැ. Can you remember those examples, like to hold something, like using the forces like T1 and the T2, like so forces applying the weight, mg. So there are many examples we done. Actually, these were according to Newton's first law of motion. I'm not going to teach you this thing again. That's enough. Knowing the Newton's first law is really essential in words. This is what we are going to learn in the first time in this class for Newton's second law of motion in the professional way. Now write Newton's second law of motion. Newton's second law of motion. Right. Good. So what is the definition of Newton's second law of motion? What is the Newton's second law of motion definition? All definition එක මතක කට්ටිය කියන්න බලන්න. All definition එක. That's not the A-level definition. But I would like to know your O-level definition if you remember. Like you learned like 2 years ago, no? Let me know if you can remember. Okay. I will teach you. You are responding, me. Right, good. That's right. The rate of change of momentum. The rate of change of momentum. The rate of change of momentum. One send me the answer with the acceleration of an object is directly proportional to the unbalanced force applied on it and the indirectly proportional to the mass of the object. Yeah, that's what O-level definition, but you can't write the same definition to here because A-level is a different level. That's why we call it A-level or the advanced level. Advanced කියන එක හේතුවක් ඇතුවනේ. Right. All right. The rate of change of momentum of an object under an external and unbalanced force. The rate of change of momentum of an object under external and unbalanced force. External and unbalanced force. Under external and unbalanced force is proportional, directly proportional to the external unbalanced force to the external unbalanced force in and applied along the direction of the force. ඔළුව කරකෝල අතෑරියා වගේද? මොකද මමත් O-level කරලා A-level කරන්න ආපු දවස්වල මට නම් ඔක එක දවසකින් තේරුණා. මගේ ඉතින් සහචරය යාළු එහෙම කියන්නේ ගොඩ දෙනෙක් සමහරුන්ට ඉතින් මගේ level එකේ ඉන්න උන්ට උඩම තේරුණා. ගොඩ දෙනෙක් ඔක කඩපාඩම් කරලා සතියක් විතර. උන්ට තේරෙන්නේ නැහැ. මම කිව්වා කඩපාඩම් කරන්න එපා බෝ. ඔක meaning එක ගනින්න. So read that again, taking like 1 minute. Read that carefully. And let me know your sincere comment, whether you understood it by the comment, sorry, the definition or not. තේරුණාද නැද්ද කියලා පොඩි comment එකක් දාන්න. පටස් කරලා විනාඩියක් අරගෙන 1 minute is gone. Now let me know whether you understood this one by the definition or not. කවුද නැද්ද කියලා කෙටියෙන් දාන්න. Just come. තමයි. බලන්න සෙට් එකක් ටයිප් කරගන්න ඔච්චර වෙලා යනවද? හා? අර ඩයල් නේ. Just to type a message, do you take this long? Yes, one said yes, the other yes. දෙන්නෙක් yes කිව්වා. තුනක් yes කිව්වා. කොළමයි? හතරක් yes. පහක් yes. කරන්නකෝ. no කියලා උත්තර දිනනවා නම් කමක් නෑ දාන්න. මම ආපහු කියලා. හරි හරි. මේ අහන්න. Okay, ඇති. You have to remember your O-level momentum. You have to remember your O-level momentum to understand. Because මම momentum කියන එක වෙනමම කරන් ඉන්න එකක්. සමහරු මැදදී momentum චුට්ටක් ගාවලා යනවා. ඒවා නිකන් මහ විහිළු වැඩ. There is a mass. And you apply certain force. It is an unbalanced force. At the beginning, it has a velocity to the right hand side. That is initial velocity of u. Right. At the end, it may reach to a kind of what? Velocity. That is v. It can be a greater one or smaller one. Greater වෙන්නත් පුළුවන්, smaller වෙන්නත් පුළුවන්. Shouldn't always be the greater. So, as a result, there should be an acceleration in that u to v, because you started at the time of t equals to 0 and you finished it at here under the time of t equals to 0. Sorry, t equals to t equals to time of t. This is what the diagram it may look like. It says at the beginning, it had a momentum of v initial. And here it has a momentum of v final. What does it say? What does it say? What does it say? The rate of change of momentum. Okay, I'll just get it to here. මම මේ පොඩි වෙනම ලෙසන් එකක් ආයි නිකන් චුට්ටක් කරනවා. The rate of change of momentum. What is it? Firstly, you should know what is momentum. So, what is momentum? O-level හරියට නැති අය ඉන්නවනේ. Mass and velocity. The momentum factor is mass into velocity. මේක තමයි momentum. What is the change of momentum? Firstly, we have to know change of momentum. Change of momentum. That means if you had an initial momentum of vi, there is a final momentum of vf. So the difference is the change of momentum. Delta p is vf minus vi. This is what change of momentum. What does it known as the rate? Rate. හය වසරේ ළමයි අහුවොත් කියයියා, if I ask what is rate පුතා, then the student might say, sir, rate means this. What the heck means rate? මොකක්ද rate කියලා කියන්නේ? ඔයාලා කියන්නේ? What is rate, guys? What is rate? තමයි rate කියන්නේ මොකක්ද? දන්නේ නැද්ද? හරි. එහෙනම් හොඳට කන තියලා අහගෙන ඉන්න. No. No, that's not rate, man. I'm asking about rate. Rate. R-A-T-E. R-A-T-E. Rate. නිකන් රටේ වගේ තියෙන්නේ. රටේ නැති ප්‍රශ්න. රටේ. What is this රටේ? කියන්න බලන්න රටේ කියලා තියෙන්නේ මොකක්ද කියලා? Rate. What is the rate? අයවසරේ නංගි කෙනෙක්ගෙන් මල්ලි කෙනෙක්ගෙන් එහෙම අහන්න එපා. මූ තියාගෙන දුව අයියා. අයියෝ ඕක දන්නේ නැද්ද කියලා. Rate means what? Change of something with time. They don't know. They don't know about this. But they know one thing. 1/time is rate. Something, whatever thing happens, n number of things happen over time of t, that is known as rate. Certain n number of t things. The rate of flow of water. ඔය වගේ ඒවා ගණන් හදනව නේද? පැයකට ලීටර් 5ක් අයින් වෙනවා ඔය වගේ. Rate of flow of water. හොඳට තේරුම් ගන්න මේ දේවල්. ටැංකිය එකකින් ඔහම ඇරලා තිබුණොත්. දන්නවනේ ඉතින් මගේ ක්ලාස් එකේදී මම ඔය මේ භාගයට නෙමෙයි උගන්වන්නේ. ඉතින්ම ඔය දේවල් කියන්නේ. මෙන්න මේ වතුර පාරක් ගලාගෙන එනවනම් what is it? රේට් කියන්නේ මේ එකතු වෙච්ච වොලියුම් එක ටයිම් එකෙන් බෙදුවා නම් හරි. පැයකට ගන්න පුළුවන් පොල් ගෙඩි ප්‍රමාණය. The amount of coconut that you can scrape within given time. පොල් ගන්න තරගයක් අවුරුදු උත්සවය තියෙනවනේ. ඊට අනිතර කොහා කෑ ගහන්න ගන්නවනේ. කොහා කෑ ගැහුවා කියන්නේ අපිට දෙයියන්ගේ පිටයි. Imagine like somebody can just scrape 8 coconuts within 15 minutes. That's the rate. That's the rate. Yeah, relative change of quantity against another. Yeah, that's it. So normally we take the rate against time. So what is the rate of change of momentum? If this is the rate of change of, this is the change of momentum. What is the rate of change of momentum? What is the rate of change of momentum? හොඳට බලා ගන්න. The rate of change of momentum is what? Delta P divided by delta T, the time taken. මෙන්න මේ කුණුහරුප ටික තේරුණාද කියන්නේ? නැත්තම් නෑ කියන්නේ. Do you understand this thing? මම අද පොඩ්ඩක් වැඩිපුර මොලේට කතා කරන්නේ. මම දන්නවා ගොඩක් ළමයි මොලේ පාවිච්චි කරන්න කැමති නෑ. එයාලා කැමති නිකන් බබ්බුන්ට වගේ පොවනවට කියලා. එහෙම බබ්බු නම් මේකේ නෑ නොහිටියට මට කමක් නෑ. මට ඕන හොඳ මීටර් ටික මීටර් නැති එකව පොවන මීටරේ වෙන්න කැමති නම් ඉන්න. මොකද ඔළුවට ඔක තේරුම් ගත්තට පස්සේ තමයි පාඩම් කරන්න ඕන කන්ටෙන්ට් එක අඩු වෙනවා. වැඩ කරන්න තියෙන ටයිම් එක වැඩි වෙනවා. That's what my theory. You have to do your own work. It's my duty is to teach you the basics with the spirit until you to understand. Can you understand what is the rate of change of momentum now? Yes or no? ළමයි හරි මට උත්තර දෙකක් හම්බුණා කියන්නේ නැති මං yes කීර්තනාට තේරිලා තව කාටද understood okay තව rate of කතන්දරේ තේරුම් නැති කවුරු හරි ඉන්නවනම් ඒත් දාන්න හරි මන්මද රාසා එයාලත් තේරිලා හරි තව හරි Okay. Let's move. ඇති උත්තර ටිකක් ආවා. Okay. What is it? The rate of change of momentum is directly proportional to the external and unbalanced force. So now what force is directly proportional to the rate of change of momentum? That means delta P over delta T. I told you what is delta P. This is like equation number 1. What is delta P? Delta P means P final minus P initial. Equation number 2. And what is P? We know P equals to mv. So delta P is going to be mv minus mu. Why? Initial final momentum is mv here. Pf is mv. Pi is mu. Make a over time of delta t. Right. Equation number 3. Now I'm going to plug this equation number 3 to 1. Let's see how the result change. On the variable again. Now force is still directly proportional to mv minus mu over time of delta t. Right, good. But there is a big problem. Why? Because this looks really ugly. I have to rearrange this m out and v minus u over t. What the heck is this v minus u over t? What is this v minus u over t? You just learned linear motion somewhere like 2 months earlier. Really good. ඔය තියන්නේ වෙඩි තියනවා වගේ මම දාද්දිම උත්තර කියාගෙන යනවා. ඔන්නෝක තමයි වෙන්න ඕනේ. This is what I need. V minus u over t means acceleration. Right. Good. Great. F is proportional to ma. Okay. Now still with the proportionality symbol. In the second or third week of this class, I taught you an important thing. But in mathematical methods for physics thinking, can you remember if there is a certain variability of x versus y, we can just write it like this way. But to make it an equation, we have to put what? Yes, really good, Sahas. We have to put this proportionality constant. That constant I'm going to take like k and y. Now it finally became an equation. I taught this thing in very early. July was the teach. Right. What can I do now? F equals to KMA. Okay. Is this the equation we used to? No. So now, by the definition, मैं මෙතෙන් වෙනකන් එන්නකෝ. මෙතෙන් වෙනකන් එන්නකෝ. මට කියන්න දේවල් ගොඩක් තියෙනවා. අර සිහාන් නිරංග කියන්නේ මට කියන්න දේවල් හුඟක් තියෙනවා කියලා එන්නේ වගේ මට මම දැන් කියනවා මට කියන්න දේවල් හුඟක් තියෙනවා කියලා. Copy කරගන්න මේක මේ ටික විතරක් ඇති මේ ටික ඕනේ නැහැ මේක extra knowledge. Copy this within like 2 minutes please. කීර්තනාගේ ඉතින් මම දන්නෝනේ වෙඩි තියලා මේ ඉපදිලා තියෙන්නේම extra strain එකක යන ගමන් එහෙම සින්න එකක් තියෙන්නේ නැත්නම් ඉතින් කොහොම වැඩ කරන්නේ නැහැ මම ලියලා ඉවරයි. මේ සමහර විතරක් ලියලා ඉවරුණාම මේ ඔහේ ලියනවා ටික නෑ ලියනවා විතර නෙමෙයි යාගේ මේ ඔළුවේ තියෙන ඔක්කොම මාර මිනිස්සෙක් මම දන්නේ නැහැ කොහොමද ඒක කරන්නේ කියලා. This is the first time I see someone like her. What the most? Right, okay. So have a good look at, I'm explaining that again. F equals to KMA, equation as X, the force requires to, what the force is defined as what? But the force requires to accelerate a unit mass under unit acceleration, no acceleration of 1 ms minus 2. Now the force becomes 1. Force unit means 1 Newton. What is it? Mass is 1 kg and 1 ms minus 2. Automatically K becomes 1. So you don't want to include 1 in an equation, just remove and write F equals ma. Okay, that's done. So another thing I have to tell you, these things are really unnecessary. Why? ඇති වැඩක් නැහැ, ඉල්ලන්නේ නැහැ. නමුත් ඔයාලට දෙනවනේ මේවා. එතකොට නිකන් හරි මම ටීච් කරලා නොතිබුණොත් ලොකු ප්‍රශ්නයක් මතුවෙනවා. අනේ අපේ සර් මේවා කියලා දුන්නේ නැහැනේ. ඉවරයි ඉතින්. කාලවරෙන්. මම ඒක අහනකොට කැමති නෑ. ඒකයි මම ඔය කියලා නැති වැඩක් තියෙන දෙයක්. කිසිම තේරුමක් නැහැ. Okay. Right. Now let's go for really simple, extremely simple example. I am ashamed of giving you this type of example. Hamak nahi, abhi हम. Example number 1. Write this. There is a box kept on frictionless surface. There is a box kept on a frictionless surface. A frictionless surface that of having a mass of 5 kg. Having a mass of 5 kg. And it is accelerating under 2 ms minus 2, under the acceleration of 2 ms minus 2. Find out the force required to produce this acceleration. Produce this acceleration. Produce this acceleration. විහිළු ප්‍රශ්නයක් මම ආස නැහැ වගේම දෙන්න. හරි. මම ඉතින් ඔයාලට හදනවා දන්නවා කියලා දන්නත් නිසා මම හදලා දාන්නම්. Just apply F equals to ma. F is equals to ma. So this is what mass is 5 and this one is 2. The force required is nothing other than some 10 newtons. හරි නේ ළමයි? Okay guys. Right. Let's write an important thing now. Newton's second law is known as law of inertia. What? Law of inertia. Newton's second law is known as what? Law of inertia. What is this inertia? Hmm? Sorry, second law කියලා first law කියලා second law කියලා මම මතක නැහැ. What did you write? Newton's first law? Huh?
Second law.
First law. First law is known as law of inertia. ඒ කියන්නේ ඉන්න විදිය වෙනස් වෙන්න තියෙන අගමැත්ත. Right? ඉන්න විදිය වෙනස් වෙන්න තියෙන අගමැත්ත. Right? The Newton's first law, second law කියලා මට වැරදිලා කිව්නේ first law. දැන් මේ Newton's second law නේ අපි කර හිටියේ මට එකපාරට කියුණා මට නිකන් මතක් වුණා මම මේක නේද කිව්වේ කියලා. Newton's first law. Right? Law of inertia. So what is inertia? Okay. Right subtopic inertia. That's really important. Inertia. අපිට කොම්බෙන්න යන්න වෙන තරක් ඕක. Inertia. Okay. Write the definition. The reluctance to change the position of motion. Right? The reluctance to change the states of motion. The reluctance to change the states of motion. The reluctance, that means the reluctance to change the state of motion. That means අපිට ඒක නතර වෙලා නම් ඉන්නේ නතර වෙලා ඉන්නමයි කැමති. යනවා නම් යන විදිහටම ඉන්නයි කැමති. Okay, reluctance to change. As an example, if this object is stopped, it doesn't like to, that means doesn't like to what? Start motion. Or in the other way, if it is moving under some velocity of v, still what? Doesn't like to change. That means too slow. Too slow or what? Too slow or what? Increase the speed. Velocity කියලා අපිට increase velocity or what? There is another thing. I told you two things. It doesn't like to slow down. It doesn't like to accelerate or increase velocity. There is another thing. හොඳට හිතලා කියන්න බෑ. ගම් මොලේ කල්පනා කරොත් කියන්න පුළුවන් මම මොකක් කියලා දීලා තියෙන්නේ මේ විදිහට. I have already explained these things. But not as the Newton's first law. But I have taught you. Yes, my dear. That is what? The change of direction or change of direction. Okay, that means it doesn't like to you to be low value. No, it doesn't like. Or with the u and to higher value of uv, it doesn't still like. Or the other one is what? Moving with the velocity of what? U, and it doesn't like to change the direction to here or here. Right? No, it still doesn't like. This is what the meaning of what? Inertia. ඕම් ඔය දේවල් ඔයාලට තේරෙන විදිහ නේද ගන්න. ඔයාලට වැඩිම ඔලුවට යන විදිහ. Just copy these ones. Okay. Copy. Good. අද වහිනවද මේ හැමතැනම මට? ආනානිකා අද වහිනවා. කොරෝනා එන්න අමාරුයි. දැන් මොන තව එකෙක් කියලා. කවුද කියන්නේ? ඒකන ලොකුවට වහිනවද? මේක මං කියනවා වහින්නේ නැහැ. Right, okay. Copy කරගන්න මහ වෙලාවක් යන්නේ නැහැ. කියන්නේ accelerate, decelerate, change of direction, nothing is allowed. Right. ඕක මම හොඳ example එකක් කියන්නම්. Right. ඊයේ කවදා හරි දවසක එරිච්ච කාය එකක් තල්ලු කරලා තියෙනවා. මේක සිංහලෙන් ඇහුවොත් තමයි සෙට් වෙන්නේ. ඊයේ කවදා හරි දවසක ඔය මේ නතර වෙච්ච කාය එකක් පොළොව ලං කරලා ඉතින් කෙලොත් කරලා තියෙනවද දන්නේ නැහැ. මම දන්නේ නැහැ ගන්නන්නේ. ලංකාවේ ගිහම මොකද ප්‍රෝඩ් නැහැ නේ. තියෙනවද? කාය එකක් හරි බයික් එකක් හරි මොකක් හරි තල්ලු කරලා තියෙනවද? Oh shit කොල්ලෙකුත් කියනව නෑ කියලා කියනවනේ. කාලවරේ. කියන්නේ යාළුවොත් එක්ක එහෙම රවුම් ගහද්දී වගේ දේවල් අනන්ත සෙට් වෙනවා. සම්මරේ. කෙල්ල දෙන්නෙක් කියනවා yes කියලා. වාව්. ඊර්තනා and තිරාසා දෙන්නම තියෙනවා. මම තව ඉන්නවද කවුරු හරි? මොකද මේක රියල් වර්ල්ඩ් එක්ස්පීරියන්ස් එක ගන්න ඕනේ. එතකොට තමයි ඒක සෙට් වෙන්නේ අම්මාට සී මේක නෙවෙයි කියන්නේ කියලා. හරි. අඩුම ගානේ මට සතුටුයි කියලා දෙන්නෙක් හරියම ඉන්න එක කරලා තියෙනවා. වාව් good. ළමයි තල්ලු කරනකොට මේක සිංහලෙන්ම කියන්න. මොකද පටන් ගද්දී තල්ලුව දාන්න හරි අමාරුයි. It's really hard to push in the first moment. To move few yards, few feet, it's really hard. Then the hardness is reducing. As the car getting some speed, we can easily push it. Right? Because why? The inertia, because of the inertia of the car, we are really unable to provide the initial motion. Once we provide the initial motion, it doesn't like to stop and it just likes to keep it moving. It just keep moving now. Now it's easy to apply the force and make the car move until the driver to start up the engine. If this, okay, now imagine like you just push this to get some speed, right? You are the one who provided this speed. At the beginning, it was 0. At the end, it had reached some velocity of v. Right. Now it's gained some sufficient velocity. Now the driver can't turn on the engine and still the brake is not working even now. He complains, Macam, start when it's not brake, and there is a wall here. What can you do? You just run forward and you try to stop. Will you be able to stop the car? You are the one actually provide all the energy to move this. Now you are the one who's trying to stop this. Actually, you can't. Why? Your energy goes against you now because the car has a really high momentum and it has an inertia. මතක තියාගන්න එයා ඉන්න විදිය වෙනස් කරන්න කැමති නෑ. Now it's moving under some velocity. It doesn't like to stop or accelerate or change of direction. What I'm trying to do is stop. Actually, I can't. The car may trample on me and just run over my body. Can you understand? Can you just understand? මං ඔය වගේ මේ බූඩු වැඩක් කරලා බලලා තියෙනවා. ආම්මු මඩද 10 11 වගේ වගේ දෙන්න ගොම් වැඩ කරලා තියෙනවා. තව මරු වැඩක් කරලා තියෙනවා. මේක නම් ඔයාලා කරලා බලන්න යන්න එපා. කරපු නැති එකෙක් ඉන්න විදියකුත් නැහැ. දැන් ඔය ගෙවල් වල බයික් තියෙන කට්ටිය ඉන්නවා. ෆුඩ් සයිකලෙත් මේක කරන්න පුළුවන්. ගෙවල් වල අයියා කෙනෙක් එහෙම ඉන්නවා නම් ඉතින් ගෙදර බයික් එකක් නැති වෙන්න බෑ. ඉතින් ගෙදර කාර් කීයක් තිබුණත් කොල්ලෙක් ඉන්න ගෙදර අනිවාර්යෙන් බයික් එකක් තියෙනවා. ගෑනු ළමයි ඉන්නවා නම් ඉතින් අක්කා කෙනෙක් ඉන්නවා නම් ස්කූටියක් නැති වෙන්න බෑ. හරි. මේ බයික් එකක there's thing called main stand. When you put the main stand on and make the gear to neutral for the scooters, you don't want to any neutral because it's already neutral. You can turn this wheel by your hand. You can turn this wheel by your hand. Now it may gain some velocity. So you know that I am a really kind of what bad and stupid dude as well. I tried these things in my school days. I just gave the momentum by myself and rotated it and tried to stop to check my arm strength. Even though I considered it like very strong, but one day it got stuck between the mud guard and the other thing called what? There is a shock absorber, and the chain case all together got stuck. Then I had to do all of the hard works to get my hand free. ඒකයි කිව්වේ කරලා බලන්න එපා හරි භයානකයි. ෆුඩ් සයිකල් එක වුණත් ඕක වෙනවා. Because it gains really high momentum. And because of the law of inertia, it doesn't like to stop. මම වගේ ලෝකේ බූඩ් වැඩ කරලා තියෙනවා. අම්මු බාන කර. එපා වෙන බූඩ් වැඩ කරපු. ඒක නිසා වල කරලා බලන්න එපා. ඔබ කරන්න. And in grade 6, I tried extremely stupidity. An extreme case of stupidity. So there is an ayah called Lalit who has a landmaster. Landmaster වල දුනා මෙන්න මේ වගේ තඩි wheel එකක්. There is a really තඩි size but iron wheel. He kept it somewhere. Me and one of my friend called Taranga just tried to start up his landmaster and ride. Fortunately, it didn't got started. If it got started, we don't know what's going to happen. We entered to his land and tried to start. It didn't got start, but we tried to rotate this wheel and try to stop. At the grade 6, and it's not my hand, Taranga's hand got stuck between, there are some kind of what, rubber belts, and it got cut, not severe cut, but it was really painful cut. I could still remember his expressions on his face. He was actually screaming. Bicycle would have done much worse cause spoken 12 cassette in the rear. Yeah. Impact. There was a thing happened to one of my friends. when I was in grade 9 and my friend was in grade 8, he lost 2 finger tips. Like, yeah, one of those qubits were removed. So it was removed from these 2 points because he tried to put the chain back into the clock wheel while he was riding the bicycle. It got stuck between the chain and the clock wheel, and he just lost 2 fingers. And he was always keen to go to become an army officer. He couldn't. Now he told me, Mashan mage angli deka ganna mage wasana. I asked, even I don't need his explanation because why? Then he got really sad. He haven't know that when he has like a kind of deformity, the army is not accepting. So he stopped schooling. At the age of 13, he went to some kind of place called not Don Bosco. I can't remember, something like that. So he started to learn some stupid thing called lathe machines. මම බයිනෝ මූඩ් පොඩි ගෙන ගන්නත් පුළුවන් නෑ ඉබන් ඔහම කරන්නේ. නෑපියන් කරේ මං වෙනම ටාගට් එකක් ගත්තා like that. So somehow now he earns. I'm pretty sure well over between 5 to 10 million a month. 5 to 10 million a month. If he became an army officer, everybody salutes him in the army, but his earning capacity is a really long valley. He told me, fortunately, Machan, this happened. I had no argument, So, momentum. Sorry, man simple වලට කියලා දෙන්නම් කොළුව පලා ගන්න නැතුව කරන්න. Inertia. Find out the plastic ball, small size of plastic ball, and a tennis ball. And if you only have, find out the leather ball. If you don't have a leather ball, no problem, no worries. Find out suitable stone in the size of a leather ball. Ask your not extremely young one because they may throw at your face. Someone around your age to throw the plastic ball. You can try to stop the plastic ball. You can easily. Tennis ball with little bit hard, but not extremely hard. The leather ball or the stone, it's really hard to stop. Why? Because these 3 balls are in the same size, but they have some other factor. The mass factor is just changing. So M3. So you can see that M1 and M2 is larger than of M1 and M3 is the largest. So what does actually the inertia contain here in the mass? What? The mass is the inertia factor. Right. If you just need to push a foot cycle, motorcycle, and a car, which one is the easiest? Foot cycle you can easily push, and the motorbike is a bit hard, but the car is extremely hard. If you are trying a lorry, damn hard. You have to be a one giant to push. තේරුණාද? mass එකේ නේද ඔය inertia කියන එක තියෙන්නේ. Now write this thing in a new line. Inertia is caused due to mass. Inertia is caused due to mass. Inertia is caused due to mass. Now write this in a new line. Cause mass. When there is a high mass, the inertia is also high. When there is a high mass, the inertia is also high. Inertia කියන එකත් high, mass එක high නම්. Okay, understood? Write an example. Write an example. A tennis ball which weighs some 40 grams and a cricket ball which weighs some 155 grams. Right? 5 grams. So both the balls are traveled at same speed of 40 meters per second. 40 meters per second. Meters per second. Both the balls strike against arms of respective batters. Arms of respective batters. Arms of respective batters. Cricket ball causes more damage. Cricket ball causes more damage and pain than the tennis ball. Because of high mass and high inertia. High mass and high inertia. අපි පොඩි ගණන් ටිකක් හදලා නිව්ටන්ස් third law වලට යමු. චූටි ඉන්ටර්වල් එකක් ගන්න ළමයි විනාඩි 20ක මම ටයිමර් එක on කරන්නම් දැන්. Did everybody hear that?
Hello, Ramai. Can you hear me? Are you there? Ramai, are you there? Good. Okay, I think everybody is back here. So how to, that means when you just push something, try to push, you have to impart all the force that you have. So as I told you, when you just try to push a car, at the beginning it's very hard. You are trying all the hard way, but it doesn't give out any desired velocity. Once it just moved, just began to move. That means it breaks the cycle of stationary inertia, and now it's just moving. Now it's very comfortable than earlier. Now it's increased the velocity, getting easier and easier. Now you can just move really fast. And now you are the one who tried to push the stop. Now you try to stop by pushing some force. Will you be successful? No, you will be just toppled over, and the car might ride on your body. That's how it is, because that's all the moment of inertia. Inertia is the reluctance to change the states of motion. The state might be stationary, moving at uniform velocity, but you have to provide some force to make it accelerated. The likes of having a mass, and if you provide some resultant force in this direction, you can make it accelerated. Now it will just get accelerated. In the opposite way is also true. So that means when you apply certain force in the opposite direction, so what is it going to get? It's going to get certain what? Negative acceleration. Negative acceleration means deceleration. That's like application of the brake. So to apply a brake even, you have to provide some force. We sometimes say, brake pada karanne, brake pada karanne. Why? That means you can't provide a resistive force against the motion. That's the simplest meaning. Most simplest meaning is what? That you are unable to provide certain resistive force against the motion. Okay? Right. And in playing cricket, when the ball comes at you, you have to put some force to change the direction of the ball. Why? Otherwise, the ball will just travel in the desired direction as it wanted. But when you provide the external and unbalanced force, the ball gets diverted from original direction and travels to another. This is all about the momentum, inertia. It's also related to the momentum. That's why it always comes out of my mind. Okay, the next thing is, I need to know, in the last week, we were just discussing something called what? Friction as a theory. The week before that, I taught you how to deal with moments. Moment means torque, turning effect. So I know that most of the students are normally struggle for what? Moment. That means the turning effect. Are you also struggling at momentum? Moment, not momentum, moment. That means the turning effect. Or struggle කරනවද? ගණක් හදන්නේ. Moments වල. Yes, no, yes, no, no. I'm talking about moment. No. Ethan said no, others. ඉක්මනට කියන්න. Okay. Now how about friction now? How about friction? Struggling or not? Friction. I'm talking about friction. Lamai? Fine. Others? And there is another thing. The lesson we learned today, we didn't go for any big calculations yet. එහෙනම් ගිහලා big calculations ටික කරමු නේද? හරිද? Guys, නිදිද වන්ද කට්ටියම? අනේ කවුරු හරි පොඩ්ඩක් කතා කරන්න බලන්න නිකන් වීඩියෝට වගේ. සහස් පොඩ්ඩක් කතා කරමු.
The time, sir, that's the problem.
Hi. Sahas is there. තව කවුද ඉන්නේ? ගෑනු ළමන්ගේ පැත්තේ. One representation is enough from any girl. නම කියලා මහන්න වෙයිද මන් තවර මේක දැන් කවුරු වෙලාවෙ ඉන්නේ ඉක්මනට දන්නේ. Chatumi. Hi. Can you speak up? Chatumi ඉතින් කතා කරන්නේ නැහැ නේ. Chatumi දෙව්මිනි. ඔය තුන් දෙනාම කතා කරන මිනිස්සු නෙමෙයි. ඒකාන්ගී ඒකාන්ගීන් දැන් බැටරි බහලාද කොහෙද? Gassy?
Yes, sir.
Hello. Okay. එහෙනම් කව අපි ගම්මුද මේ southern representation එකක්. Sydney. Hello. මට හිතෙනවා මූ සෙට් එකම 2023 ක්ලාස් එකට එක දවසකට දාලා මුගේ කියවිල්ල පොඩ්ඩක් පෙන්නන්න. හරි. අපි වැඩේ පටන් ගමු. හරි, okay. Let's start.
Guys, okay, interval is over. So we have so much of works to do. So much of works to do. So shall we just move on to the tute? Shit. The tute here. So just read only the page number 27, this part only. මෙන්න මේක විතරක් එකපාරකට කියව ගන්න පටස් ගාලා page number 27 quickly, really quickly, like within taking only 2 minutes. We are going to finish Newton's third law today. So that's why I'm rushing you to just read this Newton's second law faster. Let's resume the meeting. Here, the figure shows small rocket of mass 300 kilogram at point of take off. This question is really essential because why? There is an upward thrust. That of what the driving force actually is 5,000 and the weight downward resistive force. Now you know that the force is what? Always the resultant force. I didn't teach you that part, that yet. I only told you like F equals ma, but I didn't tell you one thing because the simple example I took without friction. If there was a friction, you always need to get this force as what? This force is not just force, it is what? Resultant force. What is it? Resultant force. Always, Newton's second law of motion is applicable on the resultant force. Have a good look at, they have given me here the answer even, but I'll explain you. It's like 5,000 Newton in the upward direction, and there is the force of 2,000 Newton, which is in the downward direction. So what is the resultant force? Resultant is towards upward. How to get the resultant? The bigger force subtracted by the smaller force. What is the bigger force? 5,000 Newton, and you have to subtract it by 2,000 Newton. The resultant is going to be but 3,000 Newton upwards. The resultant force is 3,000 Newton upwards. Okay? Understand? Oh, shit. Wait, this is 3,000. This is 3,000. The weight is 3,000. I didn't see. Yeah. The resultant is 2,000. Weight is 3,000. So it is 2,000 Newton upwards. That's the driving force. Now you can apply to Newton's second law of motion. It's 300 kilogram. So this 2,000 is the force going to apply to here. 2,000 equals to mass of 300 by acceleration. 0 to 0 cancel. What is the acceleration? 20 divided by 3, small I, 6.7 ms minus 2. Understand? Did everybody understand this? Very good. Right? Good. If anybody doesn't understand, just ask me quickly, because we have to go for the Newton's third law quickly. Please, faster. Okay. Done. John pushes 12 kilogram carton with a force of 50 Newton. It's like what? 12 kg. The cart moves with an acceleration of 2 ms minus 2. What is the frictional force? Okay. Now draw this free body diagram. Your driving force is what? 50 Newton. And there is the frictional force in the opposite direction. Remember that the friction is always in the opposite. The acceleration is towards here. Acceleration is 2 ms minus 2. Right. You should know one thing, the resultant force is also towards here. Right. How do I know the resultant? Resultant equals to 50 minus frictional force. Right. Now to apply to what? F equals ma. F is what? This one. 50 minus frictional force, and the mass is like 12 kg, and the acceleration is 2. So what is it? 50 minus F frictional equals 24. Now frictional force is 50 what? Minus 24. Frictional force is a big one. 26 Newton. You have to overcome some 26 Newton and to get it accelerated. Copy this. answers Is there anybody who can't understand why did I get the frictional force as 26? If yes, let me know. Very quickly. Okay. I think it's enough. Shall we just go to Newton's third law of motion and finish it in today? අද ඉවරයක්ම කරලා දාමුද? Newton's third law. Right. Read the page number 36 quickly. Ikmanata, page number 36 and 37. The examples ටිකක් තියෙන්නේ. Solutions ටිකත් එක්කම read කරගන්න. 36 and 37 with the solutions. හත්කාල විනාඩි 4ක් දෙන්නම් ඊළඟට විනාඩි 2ක්. You have 4 minutes, huh? No more than that. හරි. Newton's third law කියවල මොන වගේ දේවල් තේරුනේ? දැන් මේ හරිය එහෙම තේරුණාද? And this look at this details about gas pushed behind a rocket and rocket moves forward, car hits a car, and the action reaction pair. Newton's third law is kind of action to reaction pair. See the weight and the reaction force, normal reaction are one. Newton's third law pairs. And if you push the box and it just equally provide the friction, is also Newton's third law pair. So all of these are Newton's third law pairs, and it explains the answers even. See what happens when the reaction following action and the man jumping out of a canoe moves forward, and the ball hit by a bat slows down, the ball pushed back. Those things are Newton's third law pair examples and the explanations and everything together. So can you just understand what does it really mean in Newton's third law of motion? ළමයි තේරුම ගත්තද නැත්ද නැත්නම් නැහැ උනන් tell me guys, Newton's third law of motion. Third law of motion. Of motion කියන වචනේ අනිවාර්යෙන්ම දාන්න ඕනේ. මිනිසුන් ගන්න නිව්ටන්ගේ third law කියනවා. නිව්ටන්ගේ laws 10 ගානක් තියෙනවා. Okay, motion on the third law. Right. Write the definition. What is the definition? When two bodies interact on each other, right? They apply forces to one another. They apply forces to one another. One another. Apply forces one another. One another in the equally in magnitude and opposite in direction. This is how A level, yeah, not like O level. O level අපි ලියාගත්ත විදිහට A level කියන්න බෑ. When two bodies interact with each other, එහෙම තමයි අපි ලියන්නේ. Right here. Have a good look at it. This one imparts a force of F to this direction. Remember that the other object imparts a force equal but in opposite. This one is known as reaction force. And this one is known as the force. The other one is known as the reaction. One is the applied force, the other one is reaction force. Now copy this. Okay, copy these two diagrams. Then important. In your exam, they might ask the characteristics of Newton's third law pair. Right? They ask whether this one is a Newton's third law pair, like an MCQ, or just ask you to write down the characteristics. It can be anything. So this is an exam tip because in the exam they might ask this point. Now write Newton's third law pairs. Newton's third law pairs have certain 4 characteristics. Right? Certain 4 characteristics. What is the first characteristic? Always occurred in pairs. Always occurred as pairs. One is an action, one is an action, the other is reaction. One is action, the other is reaction. One is action, the other is reaction. Remember. Next things you know. What is the other one? One is action, the other. Write this in a line. The action and reaction are equal in magnitude. Action and reaction are equal in magnitude. What is the number 3? It is what? The opposite of this one. The action and the reaction are opposite directions. Act in opposite directions. Acts in opposite directions. Right? Write this in a new line. The last one. Action and the reaction acts on different bodies. Acts on different bodies. එයාලා වැඩ කරන්නේ එකට එකක් වෙනස් bodies. Action and reaction acts on different bodies. 2 different bodies. Acts on 2 different bodies. Two different bodies. හරි නේද? මොක හොඳට මතක තියෙන්න. අහන්න. Right? So, examples. All of them are new examples. Yeah. Examples. What are the examples? So you may write like a rocket impart. Write this example number 1. A rocket impart fast moving air. Out of the rocket. Applying certain force of F. Applying a certain force of F. Applying a certain force of F. And the rocket. Rocket do what? Gets the reaction force from the gas. The reaction force from the gas. And write the next one. Number 2. Foot exerts force of F against the floor. Against the floor. Or ground. Against ground. Against ground. In the backward direction. Against the ground. The backward direction. And the ground exerts a reaction force in the forward direction. Reaction force in the forward direction. හරි. ඔතනින් එහාට අර තියෙන example ඔක්කොම එක කතන්දරම තමයි මේ තියෙන්නේ. Car hits the tree, pushes the ground, and the tire pushes on the ground, and pushes on the tree, and the sprinter pushes the starting block. All these are Newton's third law pairs, and you should remember this chart because they might ask some examples like this. See, this is what the action force he put on the starting block, and the reaction force from the starting block of the swimming pool makes the motion with an acceleration on him. That's the Newton's third law pair. Good example. And this one is also a Newton's third law pair example. I just explained you. Newton's third law is nothing, but you have to write the proper definition. Proper definition, number 1. And remember these 4 laws. And the last thing is few examples with what is action and what is reaction. That's more than enough for you. Okay, guys. හරිද? And today I told you earlier there were some questions, but I told you let's do after finishing what some questions in here, and we are just unable to deal with without the prior knowledge. Didn't I tell you? Just leave. First one is here. Now let's try. Let me try it. A force of 20 Newton acts on a 4 kg object. In order to drag across a table, the object accelerates as 2 ms - 2. What is the frictional force must exist between the object and the table? How? Because the applied force is 20 Newton here, right? And the acceleration factor is going to be 2 ms - 2 only. There might be a frictional force here that's to be done with the aid of Newton's second law of motion. Let me erase this unwanted points here that I've drawn. Okay. Now the F equals to MA, but F is the resultant force. Resultant force is 20 Newton is the forward force minus F friction. That's the forward force. So I write like 20 minus F frictional equals to the what? Mass of 4 and the acceleration that of 2 ms minus 2 is 8. So what is the frictional force? Ff is going to be, frictional force is going to be 20 minus 8. Frictional force is some 12 Newton. Now can you understand how did I do it? How did I arrive at this answer? Can you understand how did I arrive at this answer now? That's why I left that question earlier first to teach you and come back to this point. That's what I wanted, because if I just explain it without explaining the Newton's second law, you might get really disappointed because he did something I don't know. But now can you understand? yes, yes, no, no. ළමයි එක මිසින් වෙනවා ෆෝන් එහෙම charge කරලා power bank එකක් එහෙම ළඟ තියාගෙන laptop එහෙම ළඟ තියාගෙන හරියට charge කරලා තියාගෙන හිටියා නම් ඔයගේ කරදර නැහැ වරකට. මම තමයි එකේ කියලා. wow. ඒ පරෝපාන. දෙව්මිනි ඉන්නවා ඒකයි CSP සහස් විකාසා කුමාර් udah karena bukan di dalam pikir jalan dan title gitu. Hari kalau muka kari question mereka mau tiba mau dia lah yang kia this one and two let's just wait. Now wait is over, no more wait. Okay, it says the what force would need to cause the sled to accelerate and 3 ms minus 2. It's a dynamic friction. Remember, dynamic friction we know. So if you draw this one as the free body diagram, there is a force, I don't know, driving force, and the frictional mu k, frictional force of kinetic here, and there is an acceleration. What is it? Acceleration of 3 ms minus 2. Acceleration only occur if there is a resultant force in that direction. So we know the resultant force is driving force minus frictional force, and I have to apply this result to F equals to MA. Again, something like the previous question I solved. It comes to here. Let's see how it is. FB, the driving force, that's what I don't know. But kinetic friction now I know 50, and M is like, what is the mass of this sledge? 50 kg is 50. 50 times 3. Okay. So the driving force has to balance all 150 plus 50. The driving force, you need to maintain this acceleration by overcoming the friction even is going to be some 200 Newton. Understand or not? තේරුණාද නැද්ද? තමයි ටක් ගාලා දාන්න. That's really good. හරි. Now I need to know one thing. Shall we try some big questions of this one? In the next week, I will provide you a very big pause entire midweek worksheet, like somewhere like at least 10 to 15 pages, big questions and simple questions according to the exam structure. Exam එකේ තියෙන structure එක හරියට ප්‍රශ්න පත්ත සෙට් එකක් දාලා ටියුට් එකක් යවන්නම් ඒක කරලා ඒක හරියට ඩිස්කස් කරලා ලබන සතියේ තව ප්‍රශ්න ටිකක් කරලා නිව්ටන්ස් ලෝ ඉවර කරමු කියලා තමයි මම නම් කියන්නේ මොමන්ටම් වලට යන්න කලින්. What is your decision? Are we going to the momentum part or just spend the next week as what? Doing this excessive work. What is your opinion? Takkara dan. I got one answer. Okay, yeah, everybody says 2 questions. Okay, in the next week, we are going to do many questions. හැමෝම මතක ඇතුව midweek worksheet එක කරලා දාපල්ලා පුතේ. මොකද ඔබ කරන්න නැතුව මෙතෙන් එන්න එපා නිකන් බුද්ධ වෙලා වගේ ඉන්න පුළුවන් නා. එහෙම නේද? හරි. වීඩියෝ එක බලන්න මතකලා. තව දෙයක්. next week එකේ නම් ඕනේ නැහැ. next week කියුණා කමන්නේ නිව්ටන්ස් ලෝ අවුල් ගියේ යාළුවෝ ඉන්නවා නම් අඬ ගහගෙන එන්න. නිව්ටන්ස් ලෝ මම ගණන් ටික ෆ්‍රී සෙමිනාර් එකක් වගේ කරා. ඒක නෙමෙයි ප්‍රධානම දේ. මොමන්ටම් පටන් ගත්තී. මොමන්ටම් නාගෙන ඉන්නවා නම් මොමන්ටම් මුලින්ම අල්ලගන්න ඕනේ නම් එන්න කියන්නේ ඒක පොඩ්ඩක් සෙමිනාර් මෝඩ් එකේ කරන් තියෙන්නේ මොමන්ටම් පාර්ට් එක. යාළුවෝ ඉන්නවද ඉතින්? අඬ ගහන්න. පොඩ අපි ඉක්මනට සිලබස් එක කවර් කරගෙන පුළුවන් තරම් ඉක්මනට හොඳ පේපර් ස්ටොක් එකක් කරලා එක්සෑම් එකට වර්ක් රෙඩි කරන්නයි මගේ නම් අර හැදෑද ඉන්න කැමති නෑ. That's it. Okay. God bless you then. Bye. Bye lamai. See you. Okay lamai, bye. See you.